Hey everybody, today we're going to talk about the Pythagorean identity, where it comes from and how you can use it, just in the basic sense so far. So we talked some about radians in the unit circle already. You guys learned that the unit circle was a circle with a radius of 1. Then you're able to drop down a line to the x-axis to show like the height and then show the horizontal distance. So the horizontal distance is x and the height is y. So just reviewing what you guys had already learned, we can talk about sine being opposite over hypotenuse. So we established that sine was y. Cosine is adjacent over hypotenuse, which is x over 1. So that's x. And then since tangent is opposite over adjacent, that's the TOA, the opposite is y and the adjacent is x. And I really should have labeled an angle down here, I'm sorry. That's theta right there. So opposite over adjacent is y over x. Since y is the same thing as sine, and x is the same thing as cosine, I can say that. So those are some identities that are true from this triangle, but then there's another really big one. If you just kind of look at this triangle just for what it is, it's a right triangle, and there's something that you guys have used a lot with right triangles, and that's the Pythagorean theorem. So for this triangle, x squared plus y squared equals 1 squared. Well, 1 squared is just 1, obviously. And we just established up there in green that x is the same thing as cosine. I'm going to write this two different ways. So cosine squared plus sine squared, since sine is the same thing as y, equals 1. Now that does look kind of funny. If you put the squared without the parentheses, that makes it look like the angle is being squared instead of the entire thing being squared. So actually the normal notation, and I know this looks strange, but it's this way. Cosine squared theta plus sine squared theta equals 1. So when the little squared is in between the cosine and the theta, or the sine and the theta, that's actually saying that the entire thing is being squared. This is called the Pythagorean identity. It is definitely going to be your friend next year in pre-calculus. You're going to use it a lot. So let's maybe talk about how we can use it with what we've learned so far. Let's start with a basic example. So you're always going to have two pieces of information. Telling me that the sine of theta is 5 over 13 is going to be helpful. That kind of tells me something about the triangle I'm dealing with. And then saying that the tangent of theta is greater than 0 talks to me about the quadrant. So let's think for just a second about quadrants. We got quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay. If tangent is greater than 0, we just learned that tangent is the same thing as y over x, or sine theta over cosine theta. That would mean that either x and y are both positive, or x and y are both negative, because a negative divided by a negative is positive. So in order for tangent to be greater than 0, that's going to happen either in the first quadrant or in the third quadrant. So I have to put that together with what they just gave me. Over here I'm underlining it in green about sine. Notice that sine is positive, so if I look back over at my quadrants, quadrant 1 and quadrant 3, sine is the y value, so which one of these has a positive y value? That would be quadrant 1. So quadrant 1 has a tangent that's positive and a sine that's positive. Okay, why do I tell you all this? Because it's going to affect the final answer. So I'm going to use my Pythagorean identity, which, by the way, some people would say is sine squared plus cosine squared equals 1. Some people say cosine squared plus sine squared equals 1. Notice both things in blue here are this one. Got my lightsaber out. Here we go. Cosine squared plus sine squared equals 1 is the same thing as sine squared plus cosine squared equals 1. Okay, I'm going to plug in what I know. If sine is 5 over 13, then this is saying that 5 over 13 squared plus cosine squared equals 1. I actually didn't ask a question. I meant to say, what is cosine? Whoops. Okay. So now I can do some math. So this is 25. This is 169. I don't know what this is. And this is 1. Now I'm going to need to solve. So I'm going to subtract 25 over 169 from both sides. And I have cosine squared theta equals 144 over 169. That's nice. I purposely picked pretty numbers. So if I'm trying to solve for cosine, I need to get rid of the squared. So I do that with a square root. So square root both sides. Now technically, if I'm taking the square root of both sides, this could be plus or minus. The square root of 144 is 12. And the square root of 169 is 13. So I actually know that cosine is either positive 12 over 13 or negative 12 over 13. And the way we figure out which one it is that we go to our quadrants over here. And remember at the very beginning of the problem, we figured out that we were talking about the first quadrant because tangent was positive and sine was positive. So I'm going to choose the positive answer. So cosine of theta equals positive 12 over 13. Let's take a look at maybe one more example. Okay, this one's definitely not going to be as pretty because I can tell 5 and 6 are not in the Pythagorean triple, so it's not going to be so pretty. But this is asking me to find the tangent of theta and the cosecant of theta if cosine of theta equals 5 over 6. And tangent of theta is greater than 0. Okay, so I'm going to maybe start with this information and try to figure out which quadrant I'm in. 1, 2, 3, 4. Tangent is positive again. I didn't mean to do the same thing, but if tangent is positive, that's going to be in this quadrant or this quadrant, since tangent equals y over x, or sine over cosine, and so either has to be a positive divided by a positive or a negative divided by a negative. Cosine is also positive, so we are definitely talking about quadrant 1. Now there are different ways to do this problem. I'm going to show you guys the trig identity way, and then I'm going to show you a way where you can draw a triangle. But if cosine is 5 over 6, I'm going to use my identity, sine squared plus cosine squared equals 1. And so I don't know what sine squared is, so I'm just going to leave it as sine squared. And then cosine is 5 over 6. So I'm just kind of working this down. Remember, we can square the top and square the bottom. And I'm going to subtract 25 over 36 from both sides. 1 is the same thing as 36 over 36. So I'm going to end up with sine squared equals